Good afternoon, everyone. I just welcome all the students to Physics Department Economic College. Today, in this video lecture, I will solve some problems based on differentiability. I discussed what is differentiability in my previous lecture. So today, let us solve some problems. So let's begin. Suppose we have the question that show that f of x is equals to modulus of x is not differentiable at x equals to 0. So based on our previous knowledge of differentiability, we will try to solve this. Okay. So let us solve it. Solution. We have what we have? Left hand derivative LHD. Okay. At x is equals to 0. If you see, this is what the value of x is given, at which we have to find what? Differentiability. Left hand derivative at x equals to 0 is equals to, we can write f of c minus h, if you remember. Okay, let me first write in this way, at x minus f of c, here c is what? 0, and here x minus 0, and here we'll be putting what? Limit x approaching to c. So since it is left hand derivative, we'll be putting what here? Minus sign. So this can be further written as limit. Now I will introduce here what? H approaching to 0, f of c minus h, that is 0 minus h minus f of 0, and here 0 minus h minus 0. Now limit h tends to 0. Here we can write what? If you put the function, we will be getting modulus of minus h minus 0, and here it is minus a, which will give me what? Limit h tends to 0. Here we have plus h, modulus of minus h is plus h, and here we have minus h, which can be further written as what? Limit h tends to 0. So if we just cancel this two, we will be left with what? Minus 1. Okay. So here my answer will be what? Minus 1. If I put h equals to 0, since there is no h, I will be getting what? Simply minus 1. So this is my left hand derivative. Now let us check right hand derivative. RHD at x is equals to what? Again 0. So this will be equals to limit x approaching to 0 plus f of x minus f of 0 x minus 0. So this can be written as limit h approaching to 0, and here f of c plus h. So I'll be writing what? 0 plus h minus f of 0, 0 plus h minus 0. So this will be equals to limit h tends to 0, and then here if you see, the function is modulus of x, so modulus of h minus 0, and here I will be left with h, which will be equals to again limit h tends to 0, here h by h. So if you cancel this, your answer will be what? 1. So we see that right hand derivative is plus 1 and left hand derivative is minus 1. Hence, right hand derivative at x is equals to 0 is not equals to left hand derivative at x is equals to 0. Therefore, the function f of x is equals to modulus of x is not differentiable at x equals to 0. So this is we have shown. Okay, so this is how we have to process. So remember this final step. If right hand derivative at x equals to 0 is not equals to left hand derivative at x equals to 0, it means the function is not differentiable at this point. Okay, but if right hand derivative is equals to left hand derivative, it means the function is derivable or differentiable at given point. Okay, let us see another example. Suppose we have the question that show that the function f of x is equals to x minus 1, and provided if x is less than 2 and 2x minus 3 if x is greater than or equals to 2 is not differentiable at x is equals to 2. Okay, so this is the question we have got. Let us see how can we proceed for the solution. The solution, we will be proceeding in the same way like the previous one. We have left hand derivative at x is equals to 2. So this will be equals to limit. So here x will tend to what? To negative, and here we will be writing f of x minus f of 2 x minus 2. So again limit h tends to 0, and here it will become what? F of 2 minus h minus f of 2 and 2 minus h minus 2, which is equals to limit h tends to 0. Now what was the function for x less than 2? Okay, if you see, I'm coming back to this. So here the function for x less than 2, since it is the left hand derivative, no? So x must be less than 2, and for that we have the function x minus 1. Okay, so we will be putting this function in place of f of x. So let us put that. So here we'll be putting x minus 1, that is x is what here? 2 minus h minus 1. So this is my f of x minus. Now I'm again coming back here. If you see, if x is equal to 2 or greater than 2, which function we have to use? We have to use this function, that is 2x minus 3, and we will be using this now for f of 2. Okay, so in place of f of 2 I will be writing 2 into 2, value of x, 2 into 2 minus 3. Divided by 2 minus h minus 2. So here 2 will cancel out and we will be left with minus h only. So this can be further written as limit h tends to 0. Here we will be having 1 minus h, and here minus 4 plus 3. and here it is minus h. This equals to limit h is equals to 0, and here if you see, this and this whole part will cancel out, that is 1 minus h minus 1 minus h, which is again equals to limit h tends to 0, and this will be cancelled out. I'll be left with minus h by minus h, and if you just cancel these two, you will be left with 1. So here the answer is 1. Okay. Now right hand derivative at x is equals to 2 is equals to limit x approaching to plus 2, and here we will be writing f of x minus f of c, that is here 2 and x minus 2. So this will be equals to limit x tending to h approaching to 0 or tending to 0, and here it will become f of c, that is 2 plus h minus f of 2. So what is the function for f of 2? Again it will be same only, that is I'll be writing here, it is 2 plus h minus 2. Then we'll be getting what? H tending to 0. Here our function will be 2x minus 3, and here also the function will be 2x minus 3. Because why I am writing here 2x plus 3, minus 3? Because here x is approaching towards the 2 from the greater side, that is from the positive side, if you remember. So here our function will be 2 into x, that is 2 plus h minus 3, minus f of 2 will be what? It will be also 2 into 2 minus 3, and here it will be h only. So this can be further simplified to h tending to 0. If you just do the simplification here, I'll be getting 4 plus 2h minus 3 minus 4 plus 3 divided by h. So here 4 will cancel out, 3 will cancel out, only 2h by h will be left. Okay, so I will be writing equals to limit h tending to 0 2h by h. So h is cancelled, I am left with limit h tending to 0 2, which is equals to 2. So here right hand derivative is this. So we see that left hand derivative at x is equals to 2 is again not equals to right hand derivative at x is equals to 2, and hence f of x is not differentiable at x is equals to 2. So this is how we have solved this. Let us see another problem again. Suppose we have another question that so that the function f of x is equals to x square sine 1 by x, provided if x is not equals to 0 and 0 if x is equals to 0, is differentiable at x is equals to 0, and f derivative of the function f at x equals to 0 is 0. So this is the question we have. Let us see the solution for this. So solution, we have left hand derivative at x is equals to 0 is equals to what I can write, limit x approaching to 0 negative f of x minus f of 0 x minus 0. This can be further written as limit h tending to 0 f of 0 minus h minus f of 0 by 0 minus h minus 0. Okay, now we will be using the function. So we know that for x not equals to 0, what the function we have? The function is x square, no? Let me write x square sine 1 by x. So in place of x, I am just going to substitute 0 minus h, or simply I will be writing what? Minus h. So minus h square, and here also minus h bracket minus f of 0. So if x is equals to 0, we have 0 only, and here it is minus h. So limit h tending to 0, it is h square, it is minus h, and here it is, this minus can be taken outside, right? So minus sine 1 by h. This will be equals to limit h tending to 0. So if you see this and this square will cancel, and minus minus sign will also cancel, we will be left with what? Sorry, h sine 1 by h. Okay, I will be left with this. So we know that if we put this h is equals to 0 here, so this will be 0 certainly, but what about this? We know that what is the maximum value of sine? It is 1. What is the minimum value of sine? It is minus 1. So we can write it like this, that 0 into oscillating number between minus 1 and plus 1. Okay, I will be getting this. So this will be ultimately equals to 0, because anything multiplied with 0 is 0 only. So this is what we have got the left hand limit. Let us check for the right hand limit now. So now right hand derivative, sorry, I have uttered limit, it is derivative. Right hand derivative at x is equals to 0 will be equals to limit x approaching to 0 plus f of x minus f of 0, and here it is x minus 0. So this can be written as h approaching to 0, and here it will be f of 0 plus h minus f of 0, 0 plus h minus 0. So this can be written further as h tending to 0, and here the function will be what? Same only, that is x square. So here it is h, so h square sine 1 by h minus 0, and here I will be writing h. So again I am getting what? Limit h tends to 0, and here this and this will be cancelled out. Okay, so I can write h sine 1 by h, and if you just put the value of h equals to 0 like the previous one, again we will be getting what? 0. So thus we see that right hand derivative and left hand derivative are equal. Okay, hence so here left hand derivative at x is equals to 0 is equals to right hand derivative at x is equals to 0. Therefore f of x is differentiable at x is equals to 0. And what will be the value of, see what we have found in the left hand derivative and the right hand derivative, that is equals to 0, right? And that is only what? The derivative of the function at x equals to 0 will be 0 only, because we have found this derivative only here in the left hand derivative and right hand derivative. So both are 0, it means derivative of the function at x equals to 0 is 0. That we can write directly. Okay. So this is our solution. So I have solved till now 3 problems. I will just request you all to solve more problems based on this. Let me give a few questions to you. Please try to solve this. Okay. So please try this. Okay. Try these problems. Question 1. So that f of x is equals to x square is differentiable at x is equals to 1, and find derivative of the function at x equals to 1. Okay. Question number 2. Discuss the differentiability of f of x is equals to x e to the power minus 1 by modulus of x plus 1 by x, provided x is not equals to 0 and 0 provided x is equals to 0 at x is equals to 0. Okay. So please try to solve these problems which I have given you. And if you have any doubts, any queries, please put in the comment box, or you can directly text me on my WhatsApp number. So with this, I am ending today's lecture. So for today, only this much. Thank you.